this is how you put together the new PVS-69 system. Your main housing is printed flat. There will be some support material you have to remove in here, but this line is supposed to stay. This line locks in on the other side of the frame, and this allows for a better water seal on the system. I'm trying to make this as close to watertight as possible. So there's some bed warpage, which causes it not to be perfect, but still enough that it's actually pretty solid on there. But yeah, I'm trying to make this as water sealable as possible. So to start out, you install your camera into the camera housing. This is a Runcam Night Eagle 3. This also works with the Phoenixes. I do not know about the Fox ears yet. I have a Fox ear on the way, and I will edit all my designs to work with a Fox ear camera, since I know a lot of you have those. Unfortunately, during printing, I might have bumped my printer and Z-shifted the entire model quite a bit. And that's on me, that's not the design or anything. I smacked into it while I was doing something, but your screen will slide in here. And this is a junk screen. This one actually went bad. Adafruit will be sending me a new one once they get replacements in. So I'm not really worried about damaging this one. It's good for prototyping now. But the screen will slide in here, and the PCB will come around on this side, and should fit very snugly into here. And your wiring harness will wrap inside and can connect to a battery on the inside, or it can stay on the outside and use this drillable external battery slot right here. And this should allow you to run an external power source. This right here will be the charging port for the battery if you choose to run an internal battery. I bought this battery thinking that it would fit, and it does not. It is actually very, very too much big. But I'm looking into some other batteries that might fit this size. Hopefully they will, because, yeah, don't really feel like buying 100 batteries. Just gonna pop this PCB out for now. If this body had printed right, I could assemble it correctly. However, your front piece, you will thread this in. I actually like to have the camera out for this part, so that way I can tell which way is up. So that cutout is where the battery, or the wires come out for the camera, and you want to get that quite a few turns in, but you want to get that so it's parallel to the screen. This is where the screen sits, is in here, but you want those to be parallel as possible, or else you're going to be looking at a crooked view. So once you have that in there, you're going to slide your camera in. If you're not running an internal battery, I recommend dropping a couple drops of glue in there just to hold this piece solid. This design has a focusable lens. So this was printed slightly smaller than the camera. And what I did is, it's probably not good for your calipers to do this, but I took my calipers and I went in this hole and I spun it and I kind of machined this hole out. And then I took the back side of the calipers, opened it up like that, and then I just spun it to machine this hole out. And you don't have to take off a lot of material, but just enough so it's a very, very snug fit. And as you thread this onto the body, the camera will be pushing into there. And I did cut this down in later designs, so it's just, you know, a smaller overall sensor face. And this one also cracked while I was fucking around with it, it broke. But you're going to thread this on, and now what you have, your camera actually moves with it. You can focus your camera. You know, you have a little bit of movement there, so you can focus your camera, because it's actually turning the camera lens. You do want to have it slightly pre-focused before you install this piece, but once it's in there, then you're able to focus it. Once that's on, you're going to go to the back side. This is a threaded piece for the lens. You'll notice that there's a break in the threads. So it is threaded, and then it kind of like goes weird, and then it's threaded again. And that line is pretty evident in the camera. So you'll take this piece, and you have your focal lens. This is a 30mm focal lens from the Google VR glasses. And you take the small jam nut, and you'll thread your small jam nut on first. I've already had this apart a couple times and back together, and used it for testing different thread sizes. And so that's why it's a little boogered up in here, but shouldn't affect it. So once your focal lens is in there, you're going to thread these two together. And it's important that you don't cross-thread it, because these plastic threads do not hold up well if you cross-thread them. And it kind of just sucks to spend another hour printing a piece just because you fucked it up. I mean, I haven't done that, of course, but, you know. So you'll thread that on there. It won't thread on too far. And if you try and tighten it too much, you'll strip it. Because the threads are cut a lot smaller for the lens piece, just because the lens has to fit through the threads. Once that's together, there we go. This jam nut should sit pretty flush with it. And if it doesn't, just kind of work the jam nut until it's flush, and you're good. Now here, you can just glue that. Put a drop of glue in there, glue it up. It's actually not tight enough. That lens is flopping around in there. Back that jam nut off a bit. Alright, the lens is solid in there. You can put a drop of glue in there, hold those two solid, because you're never going to move those again, probably. Then you can take your big jam nut. You're going to thread that one on. This one threads on very easy, because it is meant to be moved around depending on how you need it. So the body, printing vertical, you get some weirdness in the threads there. They don't turn out perfect, but it does work. So you're going to thread this whole system into the body. like I said, you don't want to cross-thread this. But once you have this in there, you're now able to adjust the focus on your screen. And there should be enough clearance to where you're never going to hit your screen with your threaded insert. I made 2 of these threaded insert sizes, one for the normal 30 millimeters, but for my people that have to wear glasses out there and have prescriptions, you can use this now without your glasses, and you can adjust the focus based on what looks best for you and your prescription. You know, I got some big old Google fucking goggly eye motherfuckers, so this is a very good point for me. But you're able to thread the entire body in and out now, and once you get to where you want it, you'll just tighten down your jam nut, and it shouldn't move on you anymore. Once this is glued, obviously this back part won't move. So, once you're that far, your PCB is going to be in there, your screen's going to be in there, your cable's going to be routing here. There's a slot for a captured nut. I changed the design a little bit because this slot, I wasn't able to fit the nut in there. You stick a captured nut in there, and you can thread your bolt down through the top. Once you do that, you can snap on your back piece. Get it lined up. So mine had a little bit of bed warp and caused this to curl away a little bit. Printing at maybe, I don't know, whatever warps the least for you is probably best. But a little bit of bed warp, maybe I could have used a brim or something, but I didn't. So we got this right here. And then when there's a battery in there, this hole is big enough for the 3S battery plug to come through, or an XT30 connector, depending on what you're using. This was planned to use the 4S plug and have that run through, and I was going to just lop off the XT30 and hardwire and solder that directly to the screen itself. And then you have your battery hole plug. You might notice that this is cracked right here, and that is now fixed in future designs. This is beefier. This side housing is a little bit beefier in newer designs, but this is the one I have printed right now. And there you have it, your fully assembled PVS-69 unit. So, comparing this unit to the VPNG lights, it's quite a bit longer, but the profile is severely reduced. And I don't know about you, but I like this smaller profile a lot better. Obviously, we can't do much about the screens. The screens are going to remain the same no matter what. However, I have ordered some 1.5-inch screens, and those are on the way. And once those arrive, I'll be able to adapt this housing design and maybe remove this block or cut down the block significantly and make it a smaller design, more able to fit those 1.5 screens. I'm also working with some people online, and we're trying to develop a PCB and screen driver, PCB that drives the LCDs, but we're trying to do a AV to digital screen conversion where we can drive a small SPI 1.5-inch round screen, and that should fit into this housing perfectly and hopefully provide a lot better resolution, as the limiting factor in these screens is their resolution, because they're not really meant to be looked at under a microscope or focal lens. Looking at the screen while it's running like this, it just looks like a very small display. These are meant primarily to put on watches, so you have a small watch, right? And that watch, that's a cool screen for your watch, whatever, But since we're looking at it through a display, we see all those pixels, and that's really the limiting factor here. But now, with this focusing, we should be able to focus out to further distances, which could help a little bit with that range issue. If you're inside, you can tighten it down, and you can focus short distance. If you go outside, you can run it out and focus long distances. It's really more dynamic that way, and I really like this housing a lot more. A lot of time went into this, so if you like it, please hit that like button, give me a subscribe, drop a comment in there, and if you really want to support my work, I have an Indiegogo for development of a thermal/night vision unit, which will use all digital hardware. Still working on that fundraiser, trying to get it built up. It isn't, however, just a donate to me type thing. I am also selling shirts, sweatshirts, and stickers on there. All, obviously 2A themed, but yeah, I think that will conclude this video. But one more thing. This is a new design I've came up with, and I am selling these as a unit. This is a MOLLE panel system. This one is a center panel, which is meant to have panels on all sides, up, down, left, right, whatever you want. This system I developed for somebody on Reddit because they were asking for it, and also realized that this would be really handy if this was sold as a product. This is tileable, is a 9x9. There's connections that will connect the two pieces together, and if you'd like to buy some of these, please let me know. I'm trying to use this as another way to fundraise, to bring these cool designs to you guys. I do want to get into the firearms designing at some point. I think there's a lot to be done with these Glock files to greatly increase their reliability and dependability. Another quick note. This is a arc rail adapter for the IR Amazon flashlights. And let me tell you that these Amazon flashlights vastly outperform these Surefire helmet lights. For one, why the fuck is it red and white? And no, that's not infrared that you're just seeing in the camera. That is red. I don't know why, but they wanted a red light. If I want to not show my signature to someone without night vision, you know, why would I even want red? If I got fucking white, why the fuck would I want red? You know what I mean? Like, it's bright as fuck too. At nighttime, it's just a bright red fucking light. It's stupid. But then there's also an IR strobe, which the camera might pick up, it might not, I don't know. But there's an IR strobe on the side too, and that's cool, I guess, but fucking red light. How stupid is that? And this concludes my video. Thank you guys. Have a great day.